Hello there, TGT Tutorials here today, giving you another video on Educast AS level computer science. By the end of this video you should be able to describe the different types of memory and caching. First of all, memory refers to any storage utilised by a computer system itself. Memory can take different capacities, different speeds, and can have different purposes. Memory can be divided into two types, main memory and secondary storage. In this video we'll look at main memory. Main memory is any memory that is directly accessed by the CPU. Examples of main memory include RAM and ROM. RAM, or random access memory, stores the currently running programs, operating systems and user files. RAM is volatile, and this means contents are lost if the computer loses its power. ROM, or read-only memory, stores the boot-up software required to initialize the hardware load settings and initiate the operating system. The contents of ROM are safe when a computer loses power, making ROM non-volatile. For a program to work, it loads instructions and data from main memory, normally random access memory or RAM. As memory runs a lot slower than the processor, the overall efficiency of the computer system is reduced, as a lot of time is wasted of the speed mismatch between the memory and the processor. This is known as the von Neumann bottleneck. To improve efficiency of a computer system, cache memory is used. Cache is a fast memory that sits between the memory and the CPU. It is used to help remove the impact of the von Neumann bottleneck. Cache memory improves efficiency by keeping data instructions that are used regularly on the cache. This means data can be retrieved much faster than if it was stored in RAM. However, with cache memory being so quick, there is a downside of it as well. It is much smaller than main memory, and it costs a lot more. The different types of cache is categorized by different levels that describe its speed, size, and how close it is to the CPU. The first type of cache is level 1 cache. This type of cache is extremely fast but relatively small and is usually embedded within the CPU itself. Level 2 cache often has a higher capacity than level 1 and as a result operates much more slowly. It could be located on the CPU or located on a separate chip altogether. Finally, level 3 cache works to improve the performance of level 1 and 2 and is typically shared by all cores of the processor. Now that you have watched this video, have a go at this following question. Just before the video ends, it is very important that you understand the speed of the different devices compared to one another. Just to recap, the processor is the fastest, then followed by cache, then RAM, with secondary storage being the slowest out of them all.